Hi, in this video I'm going to give a very quick introduction to generics in Go through a couple of examples. So the use of generics comes from the fact that sometimes you may need to write certain functions which do similar things but for different data types. So here is an example of a function called swap. So you may want to swap couple of variables, but those variables can be of type int, those can be of type string, float, anything. So for each of them you may have to write a different swap function. So that is just like essentially redundant type code, like you have to write extra code for doing the same underlying logic. So this is where generics, the concept of generics comes into picture, where you are basically writing some form of a template of a function, and that function can take any data type you want, and it will do the logic which you want and give the output. And you don't have to write multiple functions for multiple data types. So here is a simple example to show the power of generics. So here I have a function called swap, and in case of generics we write this in a bracket, we write this type t, and this can be of type any. So any means it can be integer, it can be float, it can be string. And once we wrote in this format, and then we can use this type t in as a function argument. And here I have a and b, and this function is simply returning b and a, so basically swapping the values. And how to use this, we can use it in this way. So we are defining here int a, int b, which are like 3 and 4, and then we're calling that function where I'm templating it for an int. That means it will be called for the int version of that function, and then we can simply print that the swapped values. Same thing we can do for float as well, and we pass float 64 in this case. For string as well we can do the same. So if we run this function, it prints the swapped values. So this is a very simple example to showcase what generics looks like. It can be used to do much more powerful things. So basically doing different types of logic by using less number of lines of code. So I have this another example where I have one function and it takes items of type t, so like an array of certain type, and then applies a transformation function on top of each of those, and that returns an array where each of those elements are of type u. Okay, so my input is an array of type t, and output is an array of type u, where I'm applying a function, transformation function, for each element of that array which is of type t. So in this example I can have different transformation functions for different data types. So here you can see I have this array of int. So for integers, I basically want to have the square of each of them. So here I'm defining this transformation function as a function that takes an input as an int and returns its square. So here I'm defining my input array and the transformation function, and I can simply call that function and give these two as the input, and this will print the squared values for this array. So similarly for float, I may want a different transformation function. So in this case it is just multiplying each of them by 2. And in case of strings I may want to do something completely different. So in this case it's just transforming each of those string values to uppercase. So if I run this program, I see for each of them they are transformed in the way we wanted. So for integers we are squaring, for floats we are basically doubling, and for strings we are making them uppercase. So this gives a decent introduction to the concept of generics and its power. So if I want if I want to do this without the help of generics and with including another type of function, so I may have to write like 3 different functions. one for an integer array, one for a float array, one for a string array, and then call those functions separately. Whereas in this case, I'm just calling the same function and I have in the end less number of lines of code and I'm achieving the same thing. This is a brief introduction to generics in Go. Thank you.